welcome once again to yet another exciting session of our YouTube sessions. So as you know that we are still revising May-June 2024 paper. So today we want to take a look at the rest of the questions if possible. At this stage we left from the 7.2, which was the finance question. So we understand that if you're watching this video, I'm sure you have watched some other videos, which is the first series and the second series of our revision of this May-June 2024 question paper. So that at least as you move to 7.3, we understand that you may have watched some other videos. But if you haven't, make sure after this, take your time also to watch some other videos so that you can understand how exactly we approached the previous questions from question number 1 in algebra until at this stage where we are right now. So let's get to the question 7.3. So if you're just joining us today, it's the first time, make sure that you also have time, subscribe to our channel, press notification button so that as we post more videos, you will be able to be notified of those videos. So without wasting our time, let's get into the content of the day. So 7.3, the question was about a loan. The name of this girl was Lesbana. Lesbana was granted a loan of 225,000. She was supposed to pay X, which is monthly repayment of 5.5 every month. Then this is the interest that was charged, which is 9% compounded monthly. That's why we divided by 12. So now we need to understand that since this is the given information, now what exactly is the question? The question is, how many payments will Lesbana make to settle the loan? Now in this case, we understand we shall use the loan for formula, which is the present value formula. So our present value formula is P is equal to X, open bracket, 1 minus 1 plus I exponent negative N divided by I. But I want to be able to explain something which is very important, because this woman here, when she was given a loan of 225,000, she didn't start to repay this loan immediately. She had to wait for 4 months to be able to pay off the loan. So we should understand one thing, that if she didn't start paying off the loan immediately, then these 4 months that she was waiting to pay for the loan, to start making repayments, she will be charged interest for those 4 months. So let's understand how much interest was she charged for those 4 months. That means when she starts paying, our P will not be 225,000. Our P is going to factor in those interests such that the value of P must be recalculated. So at this stage, before we can substitute and start our calculations, let us recalculate the new value of the loan after 4 months. How do we do that? We use the formula A is equal to P, 1 plus I exponent N. So let's compound this loan for 4 months and see how much is this 225,000 worthy after 4 months. Let us do that. Our A, we are looking for A. Our P is 225,000, 1 plus interest, which is 9% divided by 12. For how many months? For 4 months. So since it's for 4 months, let's make our calculation to understand how much is she supposed to pay after those 4 months. So in 4 months time, this is going to be worthy 231,826.32 cents. So that means after 4 months, this is no longer 225,000. The bank will recognize that you are not owing 225,000, but you are owing 231,826.32 cents. Let us substitute our P and get to understand how do we calculate the value of N. Let us do that. Our P is now 231,820 equals to X, which is 5.5. We open our square bracket, which we are going to have 1 subtract 1 plus interest 9% divided by 12 exponent negative N exponent negative n, and this is divided by I, 9% divided by 12. So this is our formula. We substitute P is this one. This is 0.32. Let us not forget. So this is 231, 820.32 is equals to 5.5 is equals to 5.5 bracket over this. So our x is here. We substitute here. We substitute. This is our interest, our I. So we are looking for the value of n. We want the value of n. Now let us cross multiply. We cross multiply this and divide by this. That is our next stage. Let's create space on the other side. So we are going to have to make our calculations meticulously so that we don't make any mistake. So I advise that most of the time or all the time when you are making calculations in finance, don't rush to simplify anything. Just make sure you isolate whatever you need to isolate so that you can get the value of n with a proper degree of accuracy. So let's cross multiply and divide by this, which means 231 820.32 divided by multiplied by in front 9% divided by 12 over 5.5. This is equals to 1 minus bracket 1 plus 9% divided by 12 exponent negative n. So this is how we are going to let us make sure that it's very visible. So we are saying it's equals to 1 minus 1 plus 9% over 12 exponent negative n. So you shall understand that what we have here is exponent negative n, which is the same unit here. So next step, we should exchange position of this unit comes here, this unit goes there. So we have 1 plus 9% over 12 exponent negative n is equal to 1 minus 231 820.32 bracket 9% over 12, everything over 5.5. So I guess it's very visible, as you can see. So we said the next step here, introduce logarithm here, logarithm on the other side, creating space on the other side. We are going to have to make our calculations, which means the next calculation we should make at this stage is that logarithm of 1 plus 9% over 12 negative n is equal to logarithm of this unit 1 minus 231 820 multiplied by 9% over 12, everything divided by 5.5. So this is the logarithm. So bringing down negative n comes down, logarithm of 1 plus 9% over 12 is equal to logarithm of this unit, which is 1 minus 231 820 multiplied by 9% over 12, everything over 5.5. So this is negative n multiplied by this logarithm of this unit is equal to logarithm of this unit. So finally, what we need to understand, how do we find negative n? To find negative n, we shall say that n is equals to this unit divided by this unit. So this is going to be logarithm of the unit 1 minus 231 820, 9% over 12 divided by 5.5, everything divided by logarithm of 1 plus 9% over 12. So when you are punching a calculator, make sure that you understand that this is all your numerator divided by this denominator here. So negative n, remember, is still negative. Negative n is equal to logarithm of this divided by logarithm of this. So making our calculation from that, we are going to get our answer being equals to negative n is equals to what? Is equals to negative 50,85. Negative 50,85. But we're not going to round down, we're going to round up, which means n is simply going to be 51 payments. Since n is 51 payments, don't forget she delayed paying by 4 months. So we shall add 4 on top, which means from the day she took out the loan, she's going to make 51 payments. But the whole process is going to be done in 55 months. In 55 months. So this is basically what you need to understand when it comes to finance. So the formula is very important. She delayed by 4 months. So I guess you saw what we did. So all the calculations, some other steps were not necessary, but we did put them so that you can understand that from here we introduce logarithm at this stage. After introducing logarithm here, we move to this point, bring down negative n so that you can multiply this according to the laws of logarithm. Divide both sides by the same unit, we come down to n is equals to 51 payments. So she's going to complete the payment in 51 payments. So these were finance questions for June 2024. So now let's move on to calculus, which is going to be question number 8. Let us understand what was the question for calculus. Calculus, that was question 8. So the next question, the first question was first principles. First principles. So on first principles, we should understand that on first principles, they said f of x is equal to 1 over x. Step number 1 on first principles, write down your formula first. And on your formula, we have limits. H tends to 0. We have f of x plus h minus f of x divided by h. Now f of x plus h separately, f of x plus h, it is equal to 1 over x plus h. The position where there is x, just put x plus h. That's the first step. Now the next step is substitute this into this position. F of x we have is the same thing here. So limits as h tends to 0, we have f of x plus h it has now become what? 1 over x plus h. Subtract 1 over x. Everything divided by h. But what do we see happening here? If you check properly, you can see that on the numerator, both of these are fractions. So let us find a way on how do we need to solve for fractions. So how do we solve fractions? Fractions are very easy. When they're adding or subtracting each other, as you can see in this case, as they are right now, what you need is to make sure that multiply denominators, cross multiply. That's how you solve a fraction. When there's addition and subtraction. Let us do that. So I'm going to deal with the numerator first, which means 1 over x plus h, subtract 1 over x, cross multiply x, this 1 times x, it gives you x. There's minus. 1 times this one, it gives you x plus h. Everything over, multiply these two. X plus h multiplied by x. Opening this bracket, x minus h. This is going to give you what? This is going to give you x minus h. Everything over x plus h times x. So finally, you have minus h over x plus h multiplied by x. This is what we have when we simplify from here until this stage, until this stage. This is coming to replace this in this unit. Instead of saying over h, we shall use the divided sign. So let's repeat this stage. Repeating this step, we have limits as h tends to 0. The unit here is what is exactly like this, minus h over x plus h multiplied by x divided by h over 1. So from here, this divided is this over here, so that our work will not look very scattered. It has to be as nice as possible. So we know that the next step that I'm going to do on this stage is that we should remove the divided by and replace it with multiplication. Then we exchange position of h and 1. So let us do that. Let's put times. Then we shall put 1 over h. When we do that, this is going to cancel with this, which means limits as h tends to 0. What do we now have? Minus 1 on the numerator. This is x plus h. This is 2x is 2 there. Now finally at this stage, we can now make h to be 0. When you make h to be 0, it means our answer is going to be negative 1 divided by x plus 0 times x, which is outside here. Now, when x goes inside, it means our final answer minus 1 over x squared. This is our final answer, minus 1 divided by x squared. I guess you can see every stage necessary. This numerator was solved here separately, the way we solve fractions, cross multiply, but multiply these two. That's how you get your LCD. This is your LCD here. Your LCD, multiplication of these two. So you solve this step until you get here, x and x, they cancel out. Once they're out, you are left with minus h over x plus h times x. And then you simplify. So we said here, it started being what? It started being divided by h over 1. Then we said that divided, it means you can remove divided, put multiply, but exchange positions. This is now going to be 1 over h. So maybe you're asking, where did we get the 1 over h? This is the same as h over 1. Since this h over 1, at that stage, they can multiply. When you're multiplying, exchange positions. So this is how we find the derivative. It becomes negative 1 over x squared. The next question. So our next question, let's see what was the next question. The next question, it is obvious these are rules of differentiation. So rules of differentiation that we have is that we have 8.2.1. We have, they say d over dx. Then we have square root of 4x6 plus, this is the bracket, plus square root of 2, this is x squared, outside the square root. Take note of that. Let us simplify. Step number 1 is to simplify before we find the derivative. How do we simplify? Turn the square root to be an exponent of a fraction. This way, I'm sure we know that square root of 4 is the same as 4 to the power of half. There's no difference here. It's the same thing. So we're turning a square root to become an exponent of half. Let us do that. We have 4x6 exponent of half plus root 2x squared. Let's continue to simplify. 4 exponent half, x 6 times half, plus root 2x root 2. So in this case, this is 2x to the power of 3 plus root 2x to the power of 2. because when half comes in, it goes on the same on every term. So this is what we have. 4 exponent half is 2. Now at this stage, you can find dy over dx. How do you do that? Bring down 2 times 3, 6x, 3 minus 1, 2, plus bring down 2 root 2 x, 2 minus 1, it gives you x. This is our final answer of the derivative. So once we find the derivative, this is our derivative, which means we can move on to the next question. Let's move on to the next question. What is the next question? The next question is that we need to find g derivative. We should find this, but what are we given? They say g of x is equals to 3x4 minus 4x squared plus 6. Everything divided by x squared. Before we can do anything here, let us simplify g of x. G of x can be simplified to be 3x4 over x squared. Every term here is divided by x squared. Every term divided by this, every term divided by that. Let us do that. Minus 4x squared over x squared plus 6 over x squared. So we're simplifying this one. The next step, we continue simplifying. This will give us 3x squared, 4 over 1x squared. This will give us minus 4. This will give us plus 6x negative 2. I'm sure you understand. 6 divided by x squared. X squared goes to the numerator. Because squared, we have an exponent of 2. That exponent becomes positive, negative 2. It was positive, becomes negative. Next step, now we can find the derivative. Let us find the derivative. 3 times 2, 6x. This one is 0 plus, bring down this one. This is minus 12x. This is minus 12x to the power of negative 3. As we continue, 6x, 0 is out. 0 is out, which means this is going to be minus 12 divided by x exponent 3. Since we should not leave our values in terms of negative exponent. So this is how we're supposed to find the derivative of that. So this is the question 8.2.2. Finding the derivative using rules of differentiation. Same here, using rules of differentiation. Let us move to the next question. So the next question that we have is a question which is about equation of a tangent. So which means what we need is having the knowledge of equation of a tangent. What is equation of a tangent and how do we simplify? What are the steps involved in simplifying equations of a tangent? So on this question, what we are given is that we are given f of x. F of x is 3x squared plus bx plus c at x is equal to 1. Now equation of tangent is such that we have y is equal to 9x minus 9. This is the equation of a tangent. So what we are going to do next is to understand what exactly is the question. So our question that we have here, we are supposed to find the value of b. This is b. This is b. This is c. We need b and c. But in order for us to find b and c, what we should understand is that if this is the equation of a tangent, let's think of this. How do we get to determine equation of a tangent given a normal equation? This is quadratic, which is the f of x. So step number 1, we should understand that on this equation of a tangent, this represents m, which is the gradient, m is equals to 9, the gradient. But how do we determine gradient of any equation of a tangent? The process that the gradient, which is dy over dx, is always found equals to, in this case, it's 6x plus b. 6x plus b, that's the gradient in this case. But x is equals to 1. And the gradient is known to be 9. Which means what we are going to do, make these two to be equal. Because this is m, this is m. So m already is this y is equal to, don't forget y is equal to mx plus c. So this is your m, which is 9 in this case. So let's make these two, 6x plus b. That is our gradient according to this in terms of b or in terms of x. So let us substitute x is equals to 1 and make these two to be equal. We shall solve one of them here. So which means 6x plus b is equals to 9. Our x in this case is 1 plus b is equals to 9. Let us solve this. That means b is equals to 9 minus 6, which is equals to 3. So at this stage, now we know that b is equals to 3. Since b is made to be equals to 3, what do we do next? We need to find the value of c. How do we find the value of c? Because x is equals to 1, let us find a corresponding y value using this equation of a tangent. So y is equals to 9, x is 1 minus 9. That means y is equals to 0. So if y is equals to 0 and x is equals to 1, we substitute them in the original equation because the point where the tangent crosses is common with the where the curve crosses as well. So in this case, f of x is equals to 3x squared plus bx plus c. Y is 0, x is 1. That means 0 is equal to 3 bracket 1 squared plus b. Our b is 3 bracket 1 plus c. Which means for us to be able to find c, 0 is equal to 3 plus 3. It gives us 6 plus c. Therefore, c is equal to negative 6. So finally, we found the values of b and c. These are the values of b and c. The next question on calculus, we move on to question number 9. We move on to question number 9. So on question number 9, what we have is that we are given a cubic function. There is a cubic function that needs to be simplified. So we have our cubic function. The cubic function is given. We have a cubic function. They say f of x is equals to ax cubed plus bx squared plus cx minus 5. So this is what is given, but we are also given e. It's a point along this is minus 1 is to 0. We also have g, which is 5 is to 0. These are the two x-intercepts. And our graph in this case, our graph looks in this way, looks like this. This is what the graph looks like. Our graph that we have, it looks like this. This is what the graph, this is g, which is 5. This is minus 1. So we need to understand what is the first question to this. Our first question is that we need to be able to determine values of a, b, and c. Not only determining, but to show that a in this case is 1, and that b is equals to minus 3, and that c is also equals to negative 9. So what is the process of finding those values? So what we should understand is that because we have x-intercepts, we can write our x-intercepts, put them in the equation format. If x is equal to minus 1, if x is equal to minus 1, this can be written as x plus 1 in an equation format. So this can be written like this. So next step to do is that those x plus 1, they are 2 on the same point. So squared, then we have x, this is x is equal to 5, which means x minus 5. Now let us simplify this. Let's simplify this. This will give us x plus 1, x plus 1, x minus 5. Simplifying this, we have x squared using FOIL method. X squared plus 2x plus 1. This is 2 multiplied by x minus 5. So let's simplify. This is going to be x squared plus 2x squared, 2x plus 2x, and then we have x squared times x, this is x cubed, x times this, 2x squared, x times this is plus x, then minus 5, x squared, then minus 10x, then subtract 5. So as we continue to simplify, x cubed, 2x squared, minus 5x squared, minus 3x squared. 1x minus 10x minus 9x subtract 5. So this is the equation. So coefficient of x cubed is 1, which means x is equal to 1. And this coefficient is b, which is minus 3, exactly minus 3. We have proved that these three values can be found using that process. So these are x-intercepts, they are given. So we put them in the equation format. We simplify from this stage, expand this, use FOIL method, expand that until you get to the final answer, which is given like this. So these are the values of x, of a, b, and c. Then we move on to the next question. Moving on to the next question. The next question, we are being asked to determine the minimum value. The minimum value of the graph, the minimum value, which is going to be the minimum turning point. When they talk about minimum value, they're asking you for the turning point. So we have two turning points. In a cubic function, there is what is called a local minimum and a local maximum. This is a local maximum, this is a local minimum. So for us to determine a local minimum or a local maximum, we go through the process of finding stationary points, because these are stationary points. So what is the procedure to determine stationary points of a function? Determining stationary points of a function, step number 1 is to find the derivative of x. What is the derivative? But before we can get the derivative, let us get our proper equation. Our proper equation in this case is going to be, we have f of x being equals to our a, it's 1, so x cubed, our b is minus 3x squared, our c is minus 9x, then subtract 5. So this is the equation in this case. Now, step number 1, let's find a derivative and then solve it equals to 0. We shall get x values of the turning point. Understand that. Derivative first. 3x squared minus 6x minus 9. Here's our derivative here. When you find the derivative, next step, make sure that make it to be equal to 0. That means 3x squared minus 6x minus 9 is equal to 0. Let us solve. This is a quadratic equation. Take 3 outside, x squared minus 2x minus 3 is equal to 0. 3 outside, we have x factors of negative 3, it's x minus 3, we have x plus 1 equals to 0. So therefore, x is equal to positive 3 or negative 1. That means The graph tends where x is equals to positive 3 and where x is equals to minus 1. So this is evident. So therefore, let us answer the question. The question was, and the question is, calculate the value of x, the local minimum. Value of x local minimum in this case is found at x is equals to 3. This is the local minimum, x is equals to 3. Since we found the local minimum x is equals to 3, let's move on to the next graph. The next equation, we are being asked to determine the values of x for which the values of x, creating space here, values of x for which we have a situation. The situation is such that we are given a condition. The condition is that the second derivative, when it's being multiplied by the original, bigger than 0. So let us interpret this. Interpreting this shows that this is the point of inflection being multiplied by original f of x bigger than 0. So what is our point of inflection? Our point of inflection is 6x minus 6. That is a second derivative. If you do a second derivative, it comes down to this, a second derivative. What are the solutions to this? X minus 1. We have solutions to this, x plus 1. X plus 1, which is, we have x plus 1 is squared. We also have x minus 3. These are the solutions bigger than 0. But for us to determine the solutions at which the point of inflection multiplies the original and with positive values, in this case, we shall focus where there's a point of inflection. In this case, we have, let's simplify this. 6 is outside. This means this is x minus 1. X minus 1, we continue. This is x plus 1 squared, x minus 3 bigger than 0. So our point of inflection is at x is equals to 1. X is equals to 1 here. This is where we have our point of inflection. So our point of inflection in our original graph, they can only be positive or bigger than 0 when we are dealing in this region here. This is where both of them can be multiplied and can give you a positive value. So therefore x is less than 1. Then the other solution is found at this point where the graph crosses this point and this region, values to the other side, it means x is bigger than 5. These are the two values, two answers where you can find the answer for this. Point of inflection multiplied by this, both of them are bigger than 0. Bigger than 0 in this region, both of them are positive. Bigger than 0, both of them are negative in this region. Both of them are negative. This and this, they are negative. We know negative and negative will give you what? A positive value. So this is how we find or how we determine the solutions to that. So we move on to the next question. Our next question that we have is likewise, but a bit different. So the next question in this case is that we are being asked to determine values of t. Values of t for which we have a new graph, p of x, which is given as f of x plus t. F of x plus t. They are saying where the graph is going to have two distinct roots. Two distinct roots. So redrawing this to give us this. So we have our graph. This value here is negative 5, our y-intercept. Negative 5. This is positive 5, it's given. This is negative 1, is given. So for this graph to have what is called, to have two values. It means this point has moved 5 units to cross this. It means the graph will be something like this. It crosses 2 times, 2 times, 2 times. It has 2 positive and 1 negative here. So for that to happen, it means 5 must move past this x-axis. And this value here, the turning point, must not move past this, because if it moves, we're going to have a situation which is like this, where it crosses once. So this is undesired. So therefore, we need to know what is the value of y here, what is the value of y at this point. So we need to understand how do we get the value of y at this turning point. What we know so far at this turning point is that this value is 3, but the y value we don't know. So what do we do next? We substitute the x value at this turning point into the original to find that. Let us do that. F of x was equals to x cubed minus 3x squared minus 9x minus 5. So because we have our x being equals to 3, we need y value. Y is equals to 3 exponent 3 minus 3, 3 exponent 2 minus 9, 3 minus 5. If we simplify this, we are going to get our y being equals to negative 32. Y is negative 32. This is found to be negative 32. So on our graph, since this is negative 32, that means this is the range. This is the range that k must, that t, this t must not go beyond these values for us to have that situation. So therefore, we arrange negative 5. We have negative 5 here is less than or equals to t. T is less than or equals to 32. So less than, these are the solutions. Minus 5 is less than t. T is also less than negative 32. Negative 32. This is how we're supposed to solve that equation. For us to have 2 distinct values and 1 negative root, we were supposed to solve it in this way and in this fashion. All right, we move on to the next question, which is the question about, or the question regarding what is called optimization. So we are going to talk about optimization. A question on optimization question. Let us see what was expected for the optimization question that we have here. So our optimization question that we had was such that we were supposed to understand that this was the kind of situation, this was the kind of situation we had, and we had F here, and we also had N, we had D. I am only going to redraw the half part of it, and this was given as likewise that this is E. But what we needed to understand was that this was parallel to this. So if these two are parallel, how long was this? This was B. How long was this ED here? This ED was given, since this is 2 units from this point to this point. If this was 2 units, that means this is x squared. So to find this distance, it means our ED was 2 subtract x squared. Our ED, the whole 2 units minus x squared was this value, which means this is the same, 2 minus x squared. Since they are similar, they are the same. I shall call this letter, let me put a letter. I'm going to put any letter, I'll put letter K. So, using the rules or the laws of of Euclidean rules or Euclidean laws, understanding the law of proportion, we understand that Fk here, Fk divided by Nd, this Fk divided by Nd was equals to this one, which is equal to 3 minus b. Why minus b? Because this Kd is also small letter b. From here to there is the same. So to get this distance, the whole line is 3. This is 3 minus b. Divided by what? Divided by 3. Divided by 3. So, what was our Fk? We had Fk, which is 2 minus x squared, over, what is Nd? It was 2, equals to 3 minus b, over 3. So, let us manipulate this situation to find the value of b. Let us do that. Cross multiply. 3 bracket 2 minus x squared is equal to 2 bracket 3 minus b. So opening brackets, 6 subtract 3x squared was equal to 6 minus 2b. Let us solve for b. We are solving for b in this case, which means 6 comes over here. 6 minus 3x squared minus 6. Okay, let's put them in different format, which means we are going to have 2b. In this case, this one goes over there. 6 minus 6 plus 3x squared. So therefore, 2b was equal to 3x squared. To get b, divide by 2. So we cancel out. We were going to get that b is found to be 3 over 2x squared. This is the value of b. What we've done, we've calculated the value of b. On our rectangle, our rectangle looked like this, with b here, and this distance, as we are given, that distance was given as 4 minus 2x squared. This is b, 4 minus 2x squared. So, how do we get area of a rectangle? Area of a rectangle is found by using this formula. Let us create space here. Area of a rectangle is found by multiplying length times width. Let us multiply length times width. It means area is length times width. Our length is given as 4 minus x squared minus 2x squared. Our width is now this b, 3 over 2x squared. Let us open the brackets. 3 over 2 times 4, it gives you 6x squared. 3 over 2 times this, it gives you minus 3x exponent 4. We have proved that area of x is equal to this. This is how we're supposed to prove that area of this rectangle was given as like this. Let's move on to the last question. In this case, the last question of this optimization problem. The last question of the optimization problem was now to optimize the rectangle. Optimizing area of a rectangle. Optimizing area of a rectangle. Let us optimize area of a rectangle. So optimizing area of a rectangle, we are given. So as a point of advice to the learners, if you get stuck on 10.1, usually don't need to give up, because 10.2 you could solve it without the interference or without getting 10.1 wrong. So let's move on to 10.2. Now 10.2 is where we get a maximum area. Maximum area, this is the process of optimization. We need to optimize this. How do we optimize figures or shapes in calculus? How we optimize is that we need to find step number 1, the derivative of the area. So far we know that the area is given as 6x cubed, 6x squared minus 3x4. Now for us to optimize step number 1, find the derivative and solve it to be equal to 0. Let us do that. This is 12x minus 12x cubed. So we found this. Then step number 2, let us solve this equals to 0. 12x minus 12x cubed is equals to 0. Let us solve this. 12x outside 1 minus x squared is equals to 0. 12x 1 minus x 1 plus x is equals to 0. So therefore it means x is equals to positive 1 or negative 1. These are the two values of x. These are the two values of x. Now the question wants us to find the maximum area. Where we can find maximum area, let us find the second derivative. Second derivative is such that we are going to have 12 minus 36x squared. Now we need to substitute these two values. Substituting them, x, if x becomes 1, this will give us 12 minus 36 bracket 1 squared, which is literally going to be 12 minus 36, we get negative 24. At this step, it's not about negative 24. It's about the fact that this answer is a negative. So the condition is such that if the second derivative is equal to a negative value, that is the answer that gives us a maximum area. So since this positive 1 gives us a negative value, it means that finally x is equal to positive 1. Because both of them, 1, it's negative 1, they give us negative, we can adopt x is equal to 1 because x cannot be a negative. Therefore, x is equal to 1 and x is not equal to negative 1. Finally, this is how we optimize questions in calculus. So this is the optimization process. Step number 1, derivative, make it equal to 0, solve it, get your answers. We have two values, find the second derivative, test these two values to see which value will give you a negative. Fortunately or unfortunately, both of them can give us a negative, but we cannot say that x is negative because this is measurement of something. So thank you so much for watching our videos today, and today we end it here at this question for calculus. We shall have the last video, which is going to be about the last question, which is question 11, on question 11, and only question 11, which is about probability. So for now, enjoy those videos that we've made for you, and thank you so much for watching our videos, and also don't forget to subscribe if you are new to this channel. Thank you so much.